For our fourth lesson in Module 8, we're going to be solving systems by elimination with multiplication. So essentially this lesson is the same thing as what we did back in 8.3, except we're going to have to take an additional step at the start of the problem before we can begin adding our equations together. So our goal for this lesson is to learn to multiply one or both equations in a system in order to get opposite coefficients. Let's take a look at some examples. For our first example, we have the system including 2x plus 10y equals 2, and then 3x minus 5y equals negative 17. Two conditions that we're looking for when we're solving a system using elimination. First, we're looking to see if both equations are set up in the same order or have the same kind of layout for each equation. So we see here, we have our x terms first, then our y terms, then our equal signs, and then our constant terms. So both equations are set up the same way. But the next thing we look for before we can use elimination is we look for opposite coefficients. And so here we have 2 and we have 3. Those aren't equal. They're not the same. Here we have 10 and we have negative 5. Again, those aren't equal, nor are they the same. So what we have to do here is we want to multiply one of our equations, at least one. Sometimes we might have to multiply both. We need to multiply one equation by some number in order to get opposite coefficients. So we need to think back to multiples of numbers like we did earlier a few modules ago. So we're looking at common factors. We can look at our common factors of 2 and 3, and we can look at our common factors of 10 and 5. I'm sorry, not factors, multiples. So our multiples of 2 and 3. Our multiples of 2 and 3, our least common multiple is going to be 6, meaning we would have to multiply both equations by something in order to get opposite coefficients. But here, if we look at our y terms, we have positive 10 and we have a minus 5. In order to get opposite coefficients, if we take this red equation and multiply it by 2, multiply the entire equation by 2, that'll give us a positive 10y here and a negative 10y here. That will then be good enough to use addition to get rid of one of our variables. So here's what we're going to do. We're going to put parentheses around this entire equation. And again, if we multiply it by 2, when we distribute the 2 to the negative 5y, we'll get negative 10y, which will be opposite of that. Okay? That will then allow us to add to eliminate one of our variables. So we're not going to do anything to simplify our green equation or multiply our green equation. We're just going to copy that back down, and I'm going to draw an arrow over here, and I'm going to rewrite my equation over here to the right. So I'm going to have 2x plus 10y equals 2. So here I have my equation. I just copied it down. But now I need to show the distribution of this 2 into the whole equation. In 8.3, we talked about visualizing multiplying one of the equations by negative 1, and all that did was change the sign in front of each of the numbers. Well, here we're going to take this 2 and distribute it to all three terms inside our parentheses. So when we do that, I'm going to put another arrow over here. So we have 2 times 3x gives us 6x. Bring over our minus sign. And then 2 times 5y gives me 10y. Bring over our equal sign. And then 2 times negative 7 is going to give me negative 34. And now with that work, I now have opposite coefficients. Okay? So all I did was I multiplied this entire equation by 2 in order to get me some opposite coefficients here. Now the reason I chose 2, again, 5 times 2 is going to give me 10. That's why I chose 2, because it will allow me to cancel or eliminate one of my variables. Okay? So let's go ahead and finish this up. We're going to add both of these equations together. 2x plus 6x, I can put my plus sign in front of the 6, is going to give me 8x. My 10y minus 10y is going to cancel. Bring down my equal sign, and 2 minus 34 is going to give me negative 32. Now at this point, Going to divide both sides by 8. 8's cancel, and I get x equals -4. So for my ordered pair, start off with -4. Now I have to still find the y value of my ordered pair. So I'm going to take my -4, substitute it back in for x into either of these equations. I'm probably going to go with the green equation here because the numbers are a little bit smaller. So 2 times -4 plus 10y equals 2. Do my multiplication. 2 times -4 gives me -8. Bring down my plus 10y equals 2. Now I'm going to add 8 to both sides. Scroll up a little bit. These cancel. 10y equals 10. Divide both sides by 10. And y equals 1. So if I were to graph those two lines, they would intersect at the ordered pair -4, 1. Now everything that I did here from this point and all through here, it's all things that we learned how to do in 8.3. The only thing that was different was this multiplying by 2. That's the only thing that we did that's different in this problem. And again, the reason we did multiply by 2 was so that we could have some opposite coefficients here. Alright, let's go ahead and take a look at another one like this. Next example, we have 6x plus 5y equals 7, and 2x minus 4y equals -26. Again, we're trying to get opposite coefficients here. We don't have them at this point. Right now, we have 6 and 2, and we have 5 and -4, and we want opposite coefficients. Well, in order to get opposite coefficients for my y's, that's not going to happen easily because there's not a number that I can easily multiply by 4 to give me 5. However, if I look at my coefficients in front of my x's, if I multiply this entire equation by -3, 2 times -3 will give me -6, which will then give me opposite coefficients. So that's what I'm going to choose to do. I'm going to multiply the bottom equation by -3. So I put in parentheses with the -3 out front. I'm going to show that multiplication or the distribution of the -3 into the equation. So I'm just going to copy down my first equation. I'm going to copy that down, and now I'm going to show the distribution of the -3 into the equation, into the purple equation. So I'm going to start with -3 multiplied by 2x is going to give me -6x, and then -3 times -4y. Negative times a negative, remember what happens, negative times a negative becomes positive. So I'm going to have plus 12y, and that's going to be equal to, now -3 times -26 is going to give me, again, negative times a negative, is going to give me positive 78. I hope it's 78. Alright, 78 is correct. So now I have my opposite coefficients that I was looking for, positive 6 and -6. So I'm going to go ahead and add these equations together. So when I do that, 6x minus 6x, those are going to cancel. And then 5y plus 12y is going to give me 17y is equal to 85. 17y is equal to 85. Next step, going to be to divide by 17. 17's cancel, and we get y equals 5. So the y value of our ordered pair is going to be 5. We still need to find the x value of our ordered pair. So we're going to take this 5, we're going to substitute it back into one of our equations. I'm probably going to choose to substitute it back into the black equation. All my numbers there are positive, and I don't have this big -26 to deal with. So I'm going to take this 5, substitute it back into here. If you choose to substitute it into the purple equation, totally fine. Up to you. Either way should get you the correct answer. So I have 6x plus 5 times 5 equals 7. So 6x plus 25 equals 7. Subtract 25 from both sides. '25's cancel. So 6x equals negative 18. Divide both sides by 6 to get x equals negative 18 divided by 6 is going to give us negative 3. So negative 3 comma 5 would be the ordered pair where those two equations would intersect if we were to graph them. For our last system, we have 3x minus 2y equals 2 and 5x minus 5y equals 10. Now, the difficult thing about this problem is that we're going to have to actually multiply both equations by something. Because we see that when we look at the coefficients, there's nothing that we can multiply by 3 to easily get 5, nothing we can easily multiply by negative 2 to get positive 5. Okay, so we're going to have to multiply both equations by something. Now, what you can do is you can identify the least common multiple of the pairs of coefficients. So for 3 and 15, the least common multiple would be 15. For 2 and 5, the least common multiple would be 10. I would go with whatever would get you to get to the smallest least common multiple. So here our least common multiple is 15. Here it's 10. So multiply by whatever you'd need to do in order to get these to be a 10. And then you'd be able to eliminate the y variables. You could, again, multiply to get the least common multiple of these two numbers, but then your equation is just going to get bigger. Multiply so that you get opposite coefficients for the y variables because they're going to be smaller. So the question is, what do we need to multiply our equations by in order to get opposite coefficient for the y's? Well, if we multiply our top equation by 5 and our bottom equation by negative 2, that will give us opposite coefficients. 5 times negative 2 will give us negative 10. Negative 2 times negative 5 will give us positive 10. All right, that'll give us our opposite coefficients. So let's show our multiplication. So 5 times 3x is going to give me 15x. 5 times negative 2y is going to give me negative 10y. And finally, 5 times 2 is going to give me 10. Now for distributing for my second equation, negative 2 times 5x is going to give me negative 10x. Negative 2 times negative 5y is going to give me positive 10y. Bring down my equal sign. And negative 2 times 10 is going to give me negative 20. All right, so now that I've done my distribution, I see that I have my opposite coefficients right here, and I can add my equations going straight down. 15x minus 10x is going to give me 5x. Let's try that again, 5x. Negative 10y plus 10y, that will cancel. Bring down our equal sign, and then 10 minus 20 is going to give me negative 10. So now I'm going to go ahead and divide both sides by 5. 5's cancel to give me x equals negative 2. So the first value of my ordered pair is going to make my x value, which has a total of negative 2. So now I'm going to take this negative 2, substitute it back into one of my equations up here. Don't substitute it into one of our equations that we multiplied by, because it's going to be bigger numbers that we're dealing with. Substitute it back into one of the original equations. I'm probably going to choose the purple equation here, just because it's got smaller numbers. So I have 3 times negative 2 minus 2y equals 2. Do my math. 3 times negative 2 is negative 6. Bring down my minus 2y equals 2. Now I'm trying to get the negative 2y by itself, so I add 6 to both sides. And scroll down a little bit. These will cancel. Bring down my negative 2y. Make sure that you do not forget about this negative sign right here, otherwise you will get your y value wrong. So negative 2y is equal to 8. Divide both sides by negative 2. Negative 2's cancel, and we get y equals, here we have a positive divided by a negative. That's going to give us a negative 4. Okay, so the y value of our ordered pair is negative 4. If I were to graph these two equations, they would intersect at the ordered pair negative 2, negative 4. All right. There are going to be some word problems in the video, but I believe we've done enough word problems, and I can maybe go through one more at the starter class on Thursday or so if we still need some additional support with that. All right. So hopefully at this point, you feel confident with multiplying one or both equations in a system in order to get opposite coefficients, and then with that, you are able to solve using elimination. Write down any questions or comments or concerns that you might have, and we can address those in class on Thursday. Have a good rest of your day.